Good morning, class. So before we start our problem, we'd like to present to you a little meme, okay? And so this meme says when the exam is too hard and you got to see if you're still alive. And now this is funny for two reasons. Number one, an exam probably wouldn't kill you. And number two, if you were dead, you probably wouldn't be able to check your own pulse. Okay. So here's the problem. You can pause the screen and read it, but basically what we want to do is find the maximum torque at T1 when we know that the allowable shear stress is 60 MPa. So before we start, let's go over the things that we were given in the problem. We have the diameter of the shaft, our allowable shear stress, and some formulas that may or may not be useful. So we have the torsion formula, which states that Tmax is equal to the torque times the outermost radius over the moment of inertia. Okay. So let's find the torque in TBC. That would be a good place to start. So when we do that, we get sum of the torques equal to 0, TBC plus 900 minus T1 equals 0. So TBC equals T1 minus 900. So now let's actually find the, so that's to solve for the internal torque at TBC. So now let's find the maximum torque using our maximum shear stress. So we can solve the torsion equation for torque, plug in our maximum shear stress, and then we have our moment of inertia and our outermost radius, which is C. And when we do that, we get a whopping 1472.62 Newton meters. And that is for the maximum internal torque. So we want to find the torque at TB1 or T1. We plug that into our equation that we defined by summing the moments and summing the torques, And once we do that, we get T1 is equal to 2372.62 Newton meters, or a casual 2.37 kilonewton meters. Okay, and now we have the torque at every gear, which also gives us the torque in every section if we sum the torques in the same way that we did in the last part. So we want to find the maximum shear stress in CD. We sum the torques within CD. We get 872.62 newtons. We use our torsion equation. And we get a whopping 35.6 MPa. DE, guess what? Same thing. Sum, bingo, bango, 572.6 Newton meters. Torsion formula, calculator move, 23.3 MPa. Bingo, bango, we are donezo.